Students, you should see which one of the structure here has dipole moment not 0. You look at the xenon tetrafluoride. First I am calculating the number of hybrid orbitals by using the ready-made formula half into V plus X minus C plus A. So half into valence electron on the central atom 8. Number of monovalent atoms attached to the central atom are 4. No cation, no anion. 8 and 4, 12. By 2 is 6. Out of 6, 4 are bond pair and 2 are lone pair. Okay. Xenon in the center, 1 above, 1 below, 4 in the plane, total 6. Remember, so always we keep, I will call lone pair as a loafers. Always I will place loafers at a quiet place, whether quiet place is axial or equatorial. It's a equatorial. Always I know that axial bonds are experiencing more repulsion, so noisy place. Equatorial, there are less repulsion, so they are a quiet place. But there is only one exception we have, that is the octahedral case. Even you keep lone pair at equatorial, due to maximum repulsion here, equatorial will be converted into what? Axial. In all other geometry, you keep loafers at a quiet place, equatorial. But in the octahedral case, even you keep lone pair at equatorial, itself it will gets converted into what? Axial. So keep in your mind. Okay, lone pair always equatorial. But only in the case of octahedral geometry, it will be at axial. So let me show that. We have a 2 lone pair. I am showing it at axial. Remaining we have the fluorines. Okay. So you can see the dipole moment. So always electron is more negative, so head. Electron is more negative, so head. So these two cancels each other, right? The dipole moment of this and this will get cancel each other. The dipole moment of this and this will get cancel each other. So what is the net? 0. So cannot be the answer, no? So let's go to option B, CF4. Same formula, half into valence electron of the central atom 4. Number of monovalent atoms attached to the central atom are 4. Cations not there, anions not there. 4 and 4, 8. By 2 is 4. So out of 4, all 4 are bond pair. I know carbon cannot be dsp2. Carbon cannot have D. So 4 means it has to be sp3, tetrahedral. So total 3 and 1 is 4. 1 tetrahedral. I know head is on the more electronegative, plus on the carbon, more negative plus, more negative plus, more negative plus. If you look at 1, 2, 3, these 3 dipole moments going down, it's resultant here. The fourth one, the dipole moment is here, right? You are saying that this is because of the CF bond, even it is because of the CF bond. So their magnitude has to be same, like 4 and 4. But their direction shown what? Opposite. So they completely cancels each other. So the net dipole moment 0. So cannot be the answer. Comes to C. Half into valence electron on a central atom 6. Number of monovalent atoms attached to the central atom 4. Cation not there, anion not there. 6 and 4, 10. 10 by 2 is 5. So out of 5, 4 are bond pair and 1 is lone pair. Let me show you sulfur in the center. Total 5. 1 above, 1 below and 3 in the plane. I know LP is a loafer. Loafer should be always at a quiet place. Quiet place is equatorial place. So 1 lone pair at equatorial. So lone pair comes at axial only in what geometry? Octahedral geometry. So let me show you the fluorines now. I can show you dipole here and dipole here. They cancels each other. So they cancels, right? I'll remove it. You have a dipole moment here like this. Fluorine more negative, fluorine more negative. You all can see the one dipole is here. The two dipole going this side, right? Its resultant I can show like this. Students, I know that this is because of SF, but this is because of orbital, lone pair. Because they are of different category, their magnitude is not same, only direction is opposite. It's like you have a +4 and -3. So one will remain right, so it has net dipole moment. Because their magnitude is not same, cancellation is not complete. So net dipole moment value is there. So option C we have to tick here as right answer.